All right, hey guys, we are going to look at the inverse functions. It's 1.9, and we're going to start with things we're pretty familiar with. What's the inverse or the opposite of addition? And I think we know that subtraction is the inverse or the opposite. Inverse or opposite. And then the inverse or opposite of division is multiplication. And the inverse of an exponent would be like a root, like a square root or a squared exponent. These are inverses. So we're going to apply that to this whole graphing right here. Now, these two functions are inverses. Either multiplying by 3 or taking a third of something is dividing by 3. So this is the whole multiplication division as inverses. And let's see what that looks like on the graph. So the line for 3x has a y-intercept of 0, slope of 3. Okay, so I'm going to connect these. All right, and then the 1/3 x, or x over 3, however you look at it, also has a y-intercept of 0 and a slope of 1/3, so up 1 over 3. All right, so these lines here, these are inverse operations, and what that means is, oops, if I draw the line of y equals x, let's see here, I'm gonna put this in a different color, so this line y equals x, it's got a slope of 1, y-intercept of 0, and what happens here is you've got a reflection over that line. So it's like, oh, draw this again. It's like I went like one of these diagonals and still one of those diagonals on the other side. So I can pick really any of these points. And it should be the same thing. It should be reflected over the line y equals x. We did this on a straight line. It could be any curve, any function. If they are inverse functions, it is reflected over the line y equals x. All right, so let's look at the xy chart for these guys. Okay, so for the f of x, which was our 3x, at -2, 3 times -2 is a -6. 3 times -1 is a -3. 3 times 0 is still 0. 3 times 1 and 3 times 2. Okay, so that was our f of x. The g of x is this one, the 1/3 x, or x over 3. So plugging in a -6, a third of a -6 is a -2. 1/3 of -3 is a -1. A third of 0, a third of 3, and a third of 2. Or sorry, a third of 6 is 2. Okay, so I saw graphically what it looked like, but even out of my xy chart, I can see that they have pretty much swapped my x's and y's. So like, instead of -2, 6, I got -6, -2. Instead of -1, -3, I got -3, -1. 0, 0, still 0, 0, because if you swap them, it's the same thing. But they pretty much exchange their x's and y's, which is why it's a reflection over the line y equals x. Okay, so this is graphically how I can tell if I have an inverse function. And then number 3, what's the relationship between f of x and g of x? The relationship is the fact that they are inverse functions. All right, so let's look at the definition of an inverse function. If f of g of x equals x and g of f of x equals x, then g of x is the inverse function of f of x. In other words, g is denoted by this f inverse notation. So you're going to see me reading all of these as f inverse, f inverse. So it says the domain of f must be equal to the range of f inverse, and the range of f must be equal to the domain of f inverse. Again, domain and range basically have to do with x's and y's. So what they're saying here is essentially you're swapping the x's and y's, you're swapping the domain and range. So for number 4, find the inverse function of this f of x equals 4x. Then verify that both f of f inverse of x and f inverse of f of x are equal to the identity function, which is right here. They should both equal just plain x. So to think about the inverse, I'm going to consider what we had up here. You had a 3x and a 1/3 x. They were inverses. So in this case, I've got a 4x. So I'm going to go with, instead of multiplying by 4, I'm going to do a dividing by 4. Or you can say a 1/4 of x. And I'm going to say that is my inverse function, f inverse of x. All right, now to verify this, I'm going to do f of f inverse of x. So basically, if I said like f of 2, it means I subbed a 2 in for the x. This is a bit more messy, but it's saying the same thing, f of f inverse of x. It's like I subbed in the entire inverse function in for my x. So here's my inverse function that I'm guessing is x over 4. I'm going to sub that in for the x in the original f of x function. So I get 4 times the x over 4. So this was f of f inverse of x. All right, move this over a little bit. Which the 4's divide out, and I am left with the identity function. I'm left with just the plain x. So yes, this one worked. Now, make sure that we do both of them. Again, the identity function, we're trying to make it equal in x. But I already did the f of f inverse. Let's do now f inverse of f of x, which again means I'm going to sub in the entire f of x function. So the 4x gets subbed into the f inverse. All right, so instead of x over 4, I have a 4x over 4, which means the 4's divide out, and yet again, I have the identity. I've got the plain x. So both of these are true, which means yes, we got the true identity. We got the true inverse. Your f inverse of x does actually equal the x over 4. All right, so let's look at number 5. It says, which of the functions below is the inverse function of this f of x equals 5 over x minus 2? So we have to pick one of these, and the way I can tell is if I substitute each of these in for the x in the f function, I should end up with the identity. It should make everything equal just a plain x by the time I'm done. So I'm going to try each of these here. I'm going to try, let's do the g of x. So let's see if I sub that in for the x in my f function. So if I get 5 over this entire g function, the entire x minus 2 over 5, minus 2. Okay, so then if I simplify this down, I'm going to turn my 2 into 10/5. They have common denominators. All right, I'm going to get my x minus 2 minus 10 all over 5. All right, and then I can combine some like terms and multiply by the reciprocal. All right, it's looking like these 5's do not divide out at all. So this is just going to be a 25 over x minus 12. So it doesn't equal plain x. Let's try the next one. So I'm going to sub the entire 5 over x plus 2. I'm going to sub that in for the x. So I get 5 over this whole function instead of the x, and then minus 2. All right, there's nothing to distribute for these parentheses here, so I'm going to get rid of the parentheses. And the plus 2, minus 2, all right, those are inverses. Those are gone. We're down to 5 over x. This is looking good already. And then if I multiply by the reciprocal of this fraction, multiply by x over 5, my 5's divide out. So this actually does equal x. Okay, so this is my inverse function. You can, if you want to rename it, this is your f inverse of x. All right, so it says the graph of f inverse is a reflection of the graph of f over the line y equals x. This is what we were talking about at the beginning. So here's my line y equals x. All right. And if it's a reflection over that, then I should be swapping the x's and the y's. Like I see that this is the point 1, 0. If I swap the x and y, I should hit the point 0, 1, which right here, yeah, okay, I did hit the point 0, 1. This one right here, the point 2, 1. If I swap my x and y, let's see, I should get the point 1, 2. So over 1 up 2, yep. Okay. And then I'm not going to pick, these ones in the middle are hard to tell what the actual point is. I'm going to go with this one right here. I can see is the point 5, 2. All right, so then it should, if I swap x and y, be the 0.25. So 25 right here, yeah, it actually does hit the 0.25. All right, so pretty much all the points that I see are actually giving me the inverse function. The f and g are inverses of each other. And then we do want to point out that they restricted your parabola to all the x's greater than or equal to 0. They didn't take like all the rest of it over here. All right, so why is the domain restricted? The domain had to be restricted because if it's going to actually match the other function and my square root was restricted, I couldn't have like the bottom half of this function. So for that reason, I had to restrict the f of x to match, like the domain of my f of x had to match the range of my g of x. Again, domain and range are like x's and y's. So the domain of my f, like all the x's, had to match the range of my g functions, like all the y's. Okay, so graphically we can tell, yes, all the points that I see, they have swapped the x and y, so they are actually inverse functions. All right, so horizontal line test. A function f is a one-to-one function and has an inverse function if and only if no horizontal line intersects the graph of f at more than one point. Okay, so you have in here what a one-to-one function is. So a function f is a one-to-one function, and we're going to test that out. So your horizontal line. Let's look at this graph right here. This one's a straight line. Like if I distribute the 1/2, I get a 3/2 minus 1/2 x, or in other words, negative 1/2 x plus 3/2. So there's kind of your mx plus b form. So you can see this would be a straight line hitting at, if I'm counting by a half, there's my 1/2, 2/2 or 1, 3/2, like 1.5. Oops. This is where I'm supposed to have my y-intercept. A slope of negative 1/2, so like down 1 over 2. All right, so here's my straight line here. Now let's consider a horizontal line. I'm going to treat this ruler as a horizontal line here for a sec. So if it'll go, there we go. Okay. So as I slide this horizontal line down, does it ever hit my graph more than once? And you can't possibly draw all of the horizontal lines. We're just kind of imagining this horizontal line sliding down, and like it hits once. Okay, this horizontal line hits once, this horizontal line hits once, and I'm trying to figure out, does any horizontal line hit any more than once? And on this linear function, no, it'll hit once and that's it. So for that reason, it can have an inverse function. If something does not pass the horizontal line test, if it hits more than one point, then it cannot have an inverse function. All right, let's look at the absolute value one. So my absolute value of x graph is like the sharp V here. kind of one of the parent functions that we've worked on. And if I consider this horizontal line, like as I slide the ruler down, is it ever going to hit more than 1 point? And yeah, actually this one hits more than 1 point. This one hits more than 1 point. Yeah, so because it hits more than 1 point so much, or even only if it happened once, it still would not pass the horizontal line test, meaning that it could not have an inverse function. So this one is a no. This one was a yes. All right, so the one inverse function that we actually found was, let's see, we found the inverse function off of this one, but like the next one, number 5 here, like they gave us options. We didn't really have to algebraically find out what the answer was. So let's take a look at actually figuring out what the inverse function is. So to find the inverse functions, first of all, I'm going to use the horizontal line test to even decide if it has an inverse function. And then in the equation for f of x, you have to replace your f of x with a y, interchange the roles of x and y, solve for the y, and replace the y with your f inverse of x in the new equation. Now, the last one here is to verify that f and f inverse are actually inverse functions of each other by showing that f of f inverse of x equals x, and f inverse of f of x also equals x. So this is kind of us checking our answer right here. All right, so first of all, let's see if we can even find an inverse function. So this one right here, we're gonna graph it. All right, so you're not gonna have like a graphing calculator or Desmos or whatever on your test, but I am just going to use that to let me know. It's not gonna find the answer for me or anything. I'm just gonna use this graphing calculator to tell me if I even have an inverse function. Maybe if it opens. I don't see it open, so let's go look at like GeoGebra or something. Oh, it's not letting me on there. Anyway, that's what I suggest you do, is go ahead and put it in like GeoGebra or graphing calculator or something. Just not to find your answer by any means. You're not going to get to use it on the test. It's just telling you if you even have an inverse function. And this one, you actually do pass the horizontal line test. So I'm going to go ahead and find the inverse function. So I'm going to then, so if I'm assuming it does, I'm going to then replace the f of x with a y. So instead of f of x equals, I've got y equals 5 minus x all over the 3x plus 2. All right, next step, interchange the roles of your x and y. So instead of y equals, I'm going to go with x equals. And instead of 5 minus x, I've got 5 minus y. Instead of a 3x plus 2, I've got a 3y plus 2. All right, so we have to solve for the y. So I've got a bit of algebra I got to do here. First of all, I'm going to multiply that denominator on both sides. Okay, so if I distribute the x, 3xy plus 2x equals a 5 minus y. All right, I'm trying to get just a plain y. Currently, I've got 2 different y's. I just want to see one of them though. So let's get all the y's on the same side. Deal with that first. So I'm going to add this y over to the other side, and I'm going to subtract the 2x on both sides here. So I'm at 3xy plus y equals the 5 minus 2x. Okay, but because I have a y on everything on the left side has a y, I can factor it out. I'm left with a 3x plus 1. Okay, so to solve for this y, I'm going to divide the 3x plus 1 over to the other side. So I get y equals the 5 minus 2x all over, or divided by, the 3x plus 1. Okay, so that was step number 3. Excuse me, that was step number 4, solve for the y. Next up, I'm going to replace the y with the f inverse of x. So this is going to say f inverse of x equals, instead of y equals, 5 minus 2x all over 3x plus 1. All right, so there is what I think is our inverse function. So we are then going to go on to number 6 here, where we check our answers. So I'm going to do my f of f inverse. So I'm going to plug the f of f inverse into the f. So this whole f inverse function is going into the original f function. Okay, so 5 minus, instead of an x, I've got the 5 minus 2x over 3x plus 1. Okay, so there's like my 5 minus x over 3x. Again, I'm replacing the x with the inverse function. Plus 2, okay. So let's see, this should turn out equaling an x. So I'm going to get a common denominator here. I'm going to multiply this by the 3x plus 1 over 3x plus 1. Same deal here, this 5. I'm going to multiply by a 3x plus 1 over 3x plus 1. I distributed my negative. Oops, and I need to distribute this 5 as well. So I get a 15x plus 5. There we go. So there's the numerator over the 3x plus 1. They both have the denominator of 3x plus 1. All right. So this whole thing is all divided by all this stuff. So we've got to get some common denominators. Actually, we're on track there. We're going to distribute the 3, so we get a 15 minus 6x plus 6x plus 2. Okay, it's all over that common denominator again, the 3x plus 1. Whew. All right, really messy. But the nice thing is the denominators divide out. Those are gone. So let's see if I can simplify this down. Maybe I'll put it over here. So now we've got in the numerator, I know that my positive 5 and negative 5, those add up to 0. They're gone. I am at a 15x plus 2x. So I'll put a 17x in the numerator. Denominator, I've got the negative 6x and the positive 6x. Those add up to 0. Those are gone. So I just have a 15 plus 2, so 17 in the denominator, which now the 17s divide out. So I get a plain x. It did. This messy, messy f of f inverse of x all equals just a plain x. And guess what? We only checked one of them. So we checked the f of f inverse. Let's check the f inverse of f. Okay, so that means this arrow is going to go the other way now. We're subbing this into the inverse. So this is f inverse of f of x. So 5 minus 2 times, instead of the x, I'm going to put this whole function, the whole 5 minus x over 3x plus 2. Okay, so 5 minus 2x over 3x, again, this nicely function all got substituted in, and then plus 1. Okay, so I'm pretty much going to do what I did before. I'm going to get common denominators. This 5 is also multiplied by their common denominator. Okay, so I'm going to distribute for a 15x plus 10. And then I've got a negative 10 plus 2x Okay, so that's just the numerator. Over, and then I'll distribute, I get a 15 minus 3x plus 3x plus 1, again, all over the 3x plus 1. Oh, it's supposed to be 2, just kidding. 3x plus 2. 3x plus 2. All right, so now let's see. The denominators, those divide out. I'm going to combine some like terms. 10 minus 10, okay, that's 0, that's gone. The negative 3x and the positive 3x, okay, those add up to 0, gone. I'm left with, up here, I've got a 15x plus 2x, so I'm at a 17x. And then a 15 and a 2 is also a 17. So very similar to what I had before. 17's divide out and I get a just plain x. So this tells me, yes, I found the correct inverse function, but my final answer, the inverse function, is this guy right here. All right. So let's see about doing the same thing on number 10. So I'm going to follow all these steps again. I would have to use the horizontal line test on my graph. Because it's a square root, I know that it looks like this, and it would pass the horizontal line test. So that means it does have an inverse function. And to find the inverse function, what I've got to do is replace the f of x with a y. In this case, I have a g of x, not an f of x, but same deal, I'm going to replace it with a y. Then I'm going to swap my x's and y's. So now it'll say x equals instead of y equals, and the square root of 2y minus 3 instead of 2x minus 3. Okay, so now I've got to solve for y. So I'm going to square both sides. I'm going to add the 3 over, divide everything by 2. All right, so we solved for y, and then replace the y with the f inverse of x. So I'm kind of putting the y equals first. So my f inverse of x equals, I put that first, and then I've got the x squared plus 3 all over 2. Okay, so let's see if this is the actual answer. We're going to check our work. So to do f of f inverse of x, again, it means I'm subbing the entire inverse function into the original f function. So my inverse function right here goes into this original f function. So instead of square root of 2x, I'm doing the square root of this messy fraction. 2 times that minus 3, all under my square root. So to simplify, let's see, the 2's divide out. I'm left with an x squared plus 3 minus 3. Okay, so the 3's are gone. I've got the square root of x squared, which is, yeah, just plain x, so good. Now I've got to check the other side as well. I did the f of f inverse. Let's do the f inverse of f of x. So we're going to go backwards now. We're going to take the original f of x and sub it into what we think is the inverse. Okay, so I get this big old square root instead of the x. So that whole square root is squared instead of the x squared. And then I've got the plus 3 and all over 2. Well, we know that square root squared, those are inverses. They totally undo each other. We are now down to a 2x minus 3 plus 3 all over 2. All right, the minus 3 plus 3 is 0. So I've got like just a 2x over 2 now. Well, the 2's divide out. I am down to a plain x again. So yes, we then have the correct answer. But again, my final answer is the inverse itself. The yellow stuff was me checking my answer. Okay. And if you guys need to like pause or go back and look at any of this, you are welcome to do so. All right, there we go. There's all of our inverse functions.